Alright, in this video we're going to go over the material that you need to know for Quiz 3. This includes percent problems, simple interest, and some proportions and some word problems. So let's get started. So first off, how are we going to solve percent problems? These are going to be word problems that involve percents. And on this slide I've got some keywords. We're going to use these keywords to translate a word problem into a mathematical equation. And if you were solving percent problems before, there might be other ways of solving it. But if we do it this way, this will help you solve any type of percent problem that you come across. And so we want to translate these keywords into a mathematical language in order to set up an equation. So whenever we come across the word of is going to tell us to multiply. When we have 50% of 120, for example, that means we're going to multiply 0.5 times 120. When we see the word is, that means we're going to write an equal sign. If we see what, that's telling us to use a variable. And even more specifically, if we see what percent, we're going to use a p to help us remember that, hey, we gotta make this a percent at the end. And then at the end of our, when we're answering it, to make sure our answer is a percent. If we see what number, then we'll use either n or x, and just remember that our answer should just be a number. And of course, as we're doing these word problems, we want to change all percents into decimals so that we can use a calculator. And you will need a calculator. I'm going to be using Desmos on my phone for the calculations. All right, so here are some examples that we're going to read through. So in this first example, we come across the phrase what percent. And when I see that, that's telling me I'm going to use a variable. Since it's asking for a percent, I'm going to use a p. Then I come across the word of, and of tells us that we're going to multiply. And we could use an x for multiplication, but we're going to start using other ways like a dot. So we have what percent p of means times for multiply, 132. And then feet, that's just the units, so we can ignore that. So then we come across the word is, and that tells us we have equals. And then we have the number 80. Okay, so we could just write it like this. P times 132 equals 80. And in fact, when we have a variable times a number, usually we'll put the number out in front. So I'm just going to write it this way. 132p, which means the same as 132 times p, equals 80. And now we know exactly what operation to do with what numbers to get our answer. So in this case, we want to get the p by itself. P is being multiplied by 132, so we're going to divide by this coefficient. Divide both sides by 132. So whatever we do to one side of the equation, we got to start doing to the other side. So then over here on the left, the 132s will cancel out, and we're going to have p is equal to 80 over 132. We go to our calculator, and we type it in. So what is 80 divided by 132? It comes out to 0.606060, just keeps going. But remember, what did we want? We want to answer this as a percent. So at this point, we're going to turn our decimal here into a percent by moving the decimal 2 places to the right. And so it would be 60.606. And a lot of times the directions are going to say round to the nearest tenth of a percent. So when you see round to the nearest tenth of a percent, this is what they're talking about. It says after you already turn it into percent, then you're going to round it to the 10th spot. Notice it's not before, it's after you turn it to a percent. So round to the nearest tenth of a percent. So we're going to do that here. So instead of writing 60.606 ... we're going to round to the nearest tenth of a percent, and we're going to put our answer as 60.6%. If it said round to the nearest percent, then we would round it to 61%. So there is our answer for number 1, 60.6%. Number 3, here it says 47 minutes. Okay, so 47, that's a number. We're going to write that down. Minutes, those are just units. We can ignore that. Then we come across the word is. What does is mean? It means equals. So we go ahead and write equals down. And then we have the phrase again, what percent? That's telling us that we're going to take P, and what comes after that, the word of. Of means to multiply, so we're going to have P times 158.5, but again, since we have a variable times a number, we can put that number out in front. Let me just squeeze it in there, 158.5 times P. Now this one's similar to the one above, except now the P is on the right side, but we want to get the P by itself, so again we're going to divide by the coefficient, just divide by the number that is in front of the variable, 158.5, over here 158.5, and put it into the calculator. So what do we get for this one? We have 47 divided by 158.5, and we get a decimal again, which is 0.2965299. Okay, it's got some nines there. And again, we want to turn this into a percent. So we're going to move the decimal 2 places over. So it's going to become 29.65 percent. And again, we're going to round it to the nearest tenth of percent. So we're rounding it to, again, after, not before. So we don't round it to the tenths over here. We turn it to a percent first, and then we're going to round it. So this is going to be 29.7% for our final answer. Number 5 says 37%. Okay, so that's a number, but it's a percent. Whenever we come across a percent, what do we have to do? Well, we got to turn that to a decimal. So remember, turning it to a decimal means moving it 2 places to the left. So 37% is going to become 0.37. Then we have the word of that tells us that we're going to multiply by whatever comes next. And here what comes next is a number, 146.4. Minutes, those are just units. We can ignore that. Then we come across the word is. That means equals. And here we have what? So we could use n. In this case, we're solving for a number, not a percent. And this tells us exactly what we need to do to find n. In this case, we're going to multiply 0.37 times 146.4. So 0.37 times 146.4, and that is coming out to 54.168. Now, if it doesn't say it's a round, you can just leave it like that. Or maybe it says to round to the nearest tenth. And in that case, if we round it to the nearest tenth, we would have 54.2. Number 7, what is 73%? So here it just says the word what. But since this already has a percent here, this means that the what is probably just a number. So what number is 73%? We're going to turn that into a decimal. Of means times 146. And so again, we're just going to multiply 0.73 times 146. And see what we get. So 0.73 times 146. In this case, n equals 106.58. And the last example, what percent of 123.9 minutes is 65 minutes? What percent? So here we're going to have a P. Of means to multiply. Multiply by what comes next here, 123.9. And then is means equals 65. So if you follow this strategy, it will tell you exactly what the equation is that you need to set up. And then you'll know, do I have to multiply? Do I have to divide? And, how do I solve for it? In this case, we're going to divide both sides here. We're going to take 65 divided by 123.9. Because again, we're going to divide by the coefficients in front of P. So 65 divided by 123.9. And in this case, we're getting P equals 0.52461. And if we turn that into a percent, we're going to move the decimal 2 places over, and we're going to get 52.461. But if we round to the nearest tenth of percent, that's going to be 52.5%. On the PowerPoint, I have some other examples here. All right, so the next thing I want to go over is how to find percent of change. And you see percent of change all the time. The stock market, the gas prices, the price of food. You might say that gas prices rose by 5%, or the price of food rose by 2%, or the stock market went down by 4%. They're talking about percent of change. And to do that, they are taking the difference between two amounts and dividing by the original or starting amount. So that's what we're going to do with these. We're going to take the difference divided by the original. So if we're finding the percent change from 64 tons to 82 tons, we're going to find the difference. And we always want the bigger number on top minus the smaller number. So 82 minus 64 is going to give us 18. And then we're going to take that 18 and divide it by the original. So the original is always going to be the first number because it's always from to. So don't have to read too much into it. The first number is going to be the starting number. So 18 divided by 64. 18 divided by 64 comes out to 0.28. So let me write that again, 0.28125. And again, we want to turn this into a percent. So it's going to move it decimal 2 places over. Here, the directions do say round to the nearest tenth percent. So we're going to round that to 28.1%. And we have to state if it's a percent increase or percent decrease. Well, how do we know that? Well, we look at the original and say, okay, to go from 64 to 82, did it go up or did it go down? Well, if we're starting at 64 and we go to 82, that means it's going to be an increase. It's going up in value. So this would be 28.1% increase. From $45 to $99. Again, we're going to take the difference. It's always going to be the bigger number minus the smaller number. So here we got 45, 99, 99 minus 45. That gives 4 here, and that gives a 5 here. So we got 54. What are we going to divide by? Again, it's always the original. So here we're taking 54 divided by 45. Now this one's going to be bigger than 1, so our answer is going to be bigger than 100%, which is fine. So that's going to give us 1.2. And we want to make that into a percent. So that's going to be 120. Remember the decimal has to go 2 places over. So that's 120%. And again, to get from 45 to 99, did it go up or did it go down? Well, again, in this case, it went up. So this would be a 120% increase. We'll do one more example. So from 77 hours to 34 hours. Take the difference, the bigger number, minus the smaller number. 77 minus 34. Subtract gives 43. Then we're going to divide. What do we divide by? Whatever we started with, the original. So that's 77. And take 43 divided by 77. That comes out to 0.5584. And then I'm always writing 4 decimal places because I know that I'm going to turn this into percent and I'm going to round it to the nearest tenth of percent. So this is going to be 55.8. The 8 is going to stay since it has the 4 after it. This is a percent. And then to go from 77 to 34, in this case, it went down. So this would be a 55.8% decrease. So this would be a decrease. And that would be our final answer. So that's how you find percent of change. Again, you take the difference divided by the original. Okay, in the next part here, we're going to do some more percent problems, some applications, finding the selling price of each item. And I'm going to go over a slightly different way than you might have learned about. So when you were doing these in school, here's method 1 that you probably did. So method 1, and then I'm going to give you a new improved method 2 way of doing it. But method 1 would be like, okay, here's the price. We're going to take 119.95, and then we're going to multiply that by 30%. Of course, we have to change that to a decimal. And let's see, we put that in our calculator. So 0.3 times 119.95, and that comes out to 35.985. But now that's not our answer, that's the discount. So what we would have to do is take the 119.95 and subtract off the discount, 35.985, to get our final answer. And typing that in, 35.985. And of course, since we're talking about money here, we're going to round our answer to the nearest cent. So this comes out to $83.09.965, which is going to round to 0.97. So there is our final price after the discount. Now, I said that's the way you were probably taught to do when you learned this back in elementary school. But there's a much easier way of doing it. So instead of finding the percent and then taking it off, method 2 is going to involve, my new method of doing this, is going to involve finding the percent we actually pay, because we're not really concerned about what the discount is. We want to know what is the end price. So if it is 30% off, that means we're not paying the whole 100% of it. We're paying 30% off of that. Well, what's 30% off of 100%? That means we're only going to pay 70% of the final price, of the original price. So 70%, we could just write that as 0.7 times 119.95. If we do that, we can do this in just one step. So instead of finding the discount and then subtracting the discount. So we'll get the same answer. 0.7 times 119.95. And again, we've got the $83.97 if we round it to the nearest cent. That's a much easier way to do it. And you could even do this, almost in your head, because all you have to do is take the 0.7 times about 120 to figure out what the actual value is going to be. This way works for all these type of percent problems. It's a little bit trickier when we get to markups and taxes, though. So for number 3, again, you could take 70% of this number and then find the markup and then add it to the original. But we're going to try it in this one-step process. So we have to think about, okay, what is the total percentage that we're paying? Well, of course, we've got to pay for the shoes, and now they're going to be marked up, higher price of 70%. So we're not going to just multiply by 70% because that means we're getting a discount. If we're paying for the whole thing, we're paying 100% of it plus another 70% on top of that. So we're paying a total of 170% of the original price. So what we can do is just take 1.7 times the original price of 114.95, and that will give us our markup, our final price. So let's type that in, 1.7 times 114.95, and we get a final price of 195.415. Again, since we are talking about dollars and cents, that's going to be $195.42. And that should make sense because we would expect the price to go up by quite a bit. Always make sure that your answers are making sense as you're doing these types of problems. If it's a discount, the price should be going down. If it's marked up or if it's taxed, then the price should be going up. So for number 5, we've got the original price here of $74.99. And then we've got a 5% tax on top of that. So again, we're going to pay 100% of the thing, of the shirt here. And we're going to pay an additional 5% on top of that for a total of 105%. So again, we're going to change that percent to a decimal, 1.05, and multiply it by the original, which is $74.99, to get our final price. We're going to type that into our calculator. 1.05 times $74.99. And we expect it to go up, and it does. Now it's $78, and we get 0.7395. Of course, we want to round that to the nearest penny, so we get $78.74. Now, number 7, now we've got two things going on. We've got a discount, we've got a tax. You might even have a discount, a tax, and a markup, but we can still do it the same way. And, you know, again, if we were doing this the old way, we would find the discount, take the discount. Well, you would first have to decide, do you want to do the discount first or the tax? Does it matter? Well, we're going to find out that it doesn't matter. You could take the discount and then find that price and then tax that price and add it on. Or you could tax it first and then find a discount. Either way you do it, it's not going to change the end price here. So again, we're going to do this new way. We're going to take $29.95, and first off, we have a discount of 29%. So when we do a discount, remember we're going to subtract from 100 and figure out what percentage we're actually paying. So that's comes out to 1, and then that's going to be 71%. So we're going to pay 71% of it, 29.95. But then we also have to tax it. So after we do the discount, we're going to tax it, which means we're going to pay 100% of that price plus 4% more. And that's going to be 1.04. So if we take this 0.71 times the original price and then multiply that again, I'll just put it here at the end, by 1.04, we'll get our final price. So all we are doing is multiplying these out. And it doesn't matter the order of operations, you know, multiplying things, the order here doesn't matter. And put that into our calculator, we would get 0.71 times 29.95. That gives us the discount. If you type it into Desmos, you can see the actual number, you know, pull up there. And then we're going to multiply that again by 1.04. We should expect the price to go down because it's discounted more than it's taxed. So the discount is going to take off quite a bit. So then we add a little bit of tax on it. The price is now $22.12. So that is how you find the selling price after discounts, markups, and taxes. The next thing we're going to do is to find simple interest. And to find simple interest, we're going to use this formula. The formula is A PERT. A is the amount of interest. P is the principal. That's the amount that's, you know, that we put into the loan or that we borrow. So that's the original amount. So where it says principal, think of that as the original. The annual interest rate, you know, sometimes you have an interest rate of 4%, 5%. We're going to write that as a decimal. And then the time is going to be in years. This is for simple interest. So this applies to things that have a fixed interest and that interest is not being, you know, compounded. So there's a different formula if it's compound interest. So it doesn't apply to like credit cards and things like that. So here we have A equals PRT. And then we have some more definitions here. Maturity value is going to be the amount of principal plus the interest. So if you borrowed $1,000 and you borrowed it for a couple years or whatever, you're not going to pay back $1,000. You're going to pay back that $1,000 and the interest on that loan. So the maturity value is the total amount of the principal plus the interest. And then we're going to calculate our monthly payment. And to get the monthly payment, we're going to take that maturity value and divide it by the length of the loan in months. So let's look at a couple examples. First off, we're going to find the maturity value of a 5-year $1,000 CD with 5% simple interest. So we got to do this in a couple steps. The first step is to always find the interest. So the interest here is going to be A equals P. P is the principal, the original amount, that's $1,000, times the interest rate, that's 5%. We got to make that into a decimal, 0.05. And then T is the time in years. Here it is for 5 years. So I'm going to put in 5 here. So we're going to type that into our calculator. This one's pretty easy. You probably can do this in your head, but 1,000 times 0.05 times 5 is going to come out to 250. Now that 250 is not the maturity value. I mean, you probably wish that you could borrow $1,000 and only have to pay back $250, but the maturity value is the total amount. So the maturity value here is going to be the $1,000 that we borrowed plus the interest on that of $250, and that's going to be $1,250. Example 2 says find the monthly payment for a 2-year loan of $2,000 with 7% interest. So we're going to take our 2-year loans, $2,000, 7%. So again, the first step is to always find the amount of interest. So that's A equals PRT. This time it's $2,000 multiplied by an interest rate of 7%, which is 0.07, multiplied by 2 years. Again, we want the time here, make sure it's in years, and that's going to be, let's see here, 2,000 times 0.07 times 2 comes out to 280. The next step after that is to find the maturity value. So that means adding on the $2,000 and the $280. So $2,000, the original amount, plus the amount of interest, gives us $2,280. And then we have to find the number of months that we're going to be paying this back. So it's over 2 years. So we're going to take the time here in years and just multiply that by 12 to get months. So whatever the time is in years, multiply by 12, that gives you the months. We have it over 24 months, so we're going to divide this maturity value by 24 to get the monthly payment. So 2,280 divided by 24 comes out to a nice $95 per month. Again, when you're doing these problems, make sure your answer makes sense. I mean, if we only borrow $2,000, it wouldn't make sense if we're paying back, $1,000 per month or something ridiculous. So make sure you understand what the problem is asking for and that your answer makes sense. All right, I want to go over a few more examples of simple interest. Here for number 1, we're finding the maturity value of a 3-year 1,200 CD with 6% simple interest. So again, first step is to always find the amount of interest, which we're going to use A equals PRT, and plug in. The principal is the original amount that is borrowed, or in this case saved. That's going to be 1,200. And we're going to multiply that by the interest rate, which is 6%. We turn that into a decimal, 0.06. And then multiply by the time, make sure that the time is in years. Here's 3 years. So we're going to put in 3. Type that into our calculator. So we have 1,200 times 0.06 times 3, and that's coming out to 216. And then again, the maturity value is the total amount. So that's going to be the principal plus the amount of interest. The principal was $1,200 and the interest is $216. So the maturity value is going to be $1,416. So that's the total amount that would have to be paid, or that in this case we would get back from the bank. For number 2, find the monthly payment for a 4-year loan of $2,400 with a 6.5 interest rate. We have A equals PRT. This time we're going to find the monthly payment. So we got to go one more step. Again, we start with finding the interest. So the P here is the original loan amount, $2,400. 6.5, again, we want to turn that into a decimal, so 0.065. And then multiply that by 4. And let's see what we get for that one. 2,400 times 0.065 times 4. And in this case, it looks like it's coming out to $614.40. We're going to add that to the original amount to find the maturity value first. So it's going to come out to $3,014.14. 40 cents. Let's have a typo there. 40 is this number. And now that we have that, we want to find the monthly payment. So we have to find out how many months. So to find out the number of months, we're just going to take the number of years and multiply that by 12. And 4 years is 48 months. So we're going to take $3,014.40 and divide that by 48. And that is coming out to $62 and 62.8 or $62.80. Okay, and last one, number 3 here. This one's a little bit different because this one has the loan time in terms of months. So when we have A equals PRT. P is the principal. Okay, that's $3,500. Then we have the interest rate of 4.5. That's going to be multiplied by 0.045. And then 18, we want this first into years. So we're going to take 18 and divide it by 12. And you can put this in as a fraction or a decimal, as long as the decimal is pretty nice. In this case, 18 divided by 12, that's going to be 1.5 or 3/2. And we can put that in there. And see what we get. 3,500 times 0.045 times 1.5 years. And that comes out to $236.25. We're going to add that to the original 3,500. That's going to come out to $3,736.25. And then we want to divide by the number of months. Here we don't have to convert the number of months because it's already in months. We want to divide that by 18. So 3,736.25 divided by 18. And here we're going to have to probably round it to the nearest cent. Comes out to 207.569. And we're going to round that to the nearest hundredth. So we're rounding to the nearest cent, $207.57. And that's how we solve simple interest. Okay. The next thing I want to go over is how to set up proportions. And we already said what proportions are. They're where we have two ratios or two rates equal to each other. And you know that we have to set them, when we're solving them, to cross multiply and divide. Now we're going to practice setting them up. from a word problem. And when we're setting these up, we have to make sure that we're comparing the same thing in the same order on both sides. So I always say we're going to compare apples to oranges. Then we have to make sure we're comparing apples to oranges. Okay, we don't compare apples to oranges and then oranges to apples. We can't flip the order around. So whatever order we decide on the left side, we have to make sure that we have the same order on the right side. So here's a couple examples. So we'll just look at a few of these. The money used here in Switzerland is called the franc. The exchange rate is 9 francs for $7. How many dollars? Find out how many dollars you would receive if you exchanged 27 francs. So the first thing here gives us a exchange rate. It even says that, so we can use that as one side. And when we're setting up the rate here, it might help to put the units on here. So we got 9 francs, and then we got $7. And then we want to set up the other side here. And to determine what goes where, that's why we have the units here, because this is 27 francs. And on the left side, we have francs on top and the dollars on the bottom. So when we go on the right side, we need to make sure it's the same way. We want francs on top and dollars on the bottom. So the 27, of course, is going to go with the francs. And we're solving for dollars, so we want to put a variable in there. And after you have it set up, we don't need these units anymore, so we can erase those. And so this is what our proportion is going to look like. 9/7 is equal to 27 over x. A simple way to do this one, you could cross multiply and divide. But notice that if I take 9 times 3, that's going to give me 27. And so 7 times 3 is going to give me whatever x is. X in this case is going to be $21. So after you have it set up, then you can just solve it as we did last time. 9x equals 7 times 27, and then divide by 9. And again, you're going to get x equals 21. Number 3. Leah bought 15 peaches for $9. How many peaches can Mike buy if he has $3? Okay, so again, this first set of information tells us how we can set it up. And keep in mind, there might be more than one way to set it up correctly. So for example, we could have the peaches on top and the dollars on the bottom. But once we decide how one side is set up, then that's going to set in stone how the other side has to go. So here we need peaches on top and dollars on the bottom. Since he has $3, we're going to put that on the bottom, and then we'd have x on top. So this is one way you can set up. You could also say 9 over 15 equals 3 over x. So now we're comparing dollars to peaches, dollars to peaches. So either way, you should get the same answer. So if we cross multiply here, we get 9x. 15 times 3, that's 45. Divide by 9, and we're going to get x equals 5. So 5 peaches. Again, make sure your answer is making sense. And then number 5 here, this is giving us kind of like a geometry problem, and we're going to have some geometry problems as well. So this says that a photo is 12 inches tall and 8 inches wide, 18 inches wide. So it's going to be a little bit wider. So just when you have a geometry problem, if you're able to, draw a picture. So it's 12 inches by 18 inches. And then it's going to be reduced, so it's going to get smaller. And it says that the height now is 2 inches. So that's going to go there. And we want to find out how wide it is, so that's going to go there. And again, there's multiple ways that we can set this up. So we can compare the height to the height. So we can say 12 over 2, going from the big to the small. So then the other side, how are we going to set this up? Well, we're going from the big to the small. Would be 18 over x. That's one way to set it up. We could also do 12 over 18. Now we're comparing the height to the width of the big rectangle, and then we want height to the width of the small rectangle. So we could do 2 over x. Okay, and we could even flip these. We could flip these. We could get the same proportion. So you can see either way we set it up, we're going to get 12 times x equals 2 times 18, which is 36. Divide by 12. Divide by 12. We get x equals 3. And put that back in here. It should make sense because over here you can see that the height is not quite as much as the width. And here the height is less than the width. The width is going to be bigger. So again, check to make sure that your answer is actually making sense. And the last thing I want to do is some geometry problems. Same thing. Now these are similar. So when we have similar figures, that means that it just means that they're enlarged or they're reduced at the same scale. So it's like you're taking a photocopy of it, or you're enlarging it or shrinking it. These are going to be proportional. So all the sides are going to be in proportion. And for the first two here, we've just got two sides and then we got a missing side. So we got to set up a proportion. So notice here on the for number 1, on the left, we've got 45. That's the short side of the left triangle. And then we got 50. That's longer. And here, 9 is the shorter side. X looks like it's the longer side. So we can set up a proportion. And again, several different ways. So we could go the shorter side to the longer side, 45 to 50. So we're comparing short to long. And this is from the left triangle. And now we want to do it the same way for the right triangle. So which number is going to go on top? Well, the shorter side has to go on top. So that's going to be the 9. And then the x is the longer side. So it's going to go on the bottom. And so now we have our proportion. Cross multiply. We get 45 times x equals 50 times 9 is 450. Divide by 45. Divide by 45. We're getting x is equal to 10. And again, check to make sure your answer is actually making sense with the picture. This side is longer, a little bit longer, so 10 seems like a reasonable answer. I'll do one more here for number 4. Now you've got more information than what you actually need, because when we set up a proportion, we only need 1, 2, 3, 4 numbers, 4 things to put in our proportion. So for number 4 and also for number 3, you've got extra information. Now you have to use the x because that's what we want to solve for. So sometimes it helps when you got a geometry problem like this, think about which sides are the longest, which are the shortest, and which ones are in the middle. So, you know, on the triangle here on the left, this is our short side, the L here is our long side, and the 11 is kind of our medium side. And we can do the same thing for the triangle on the right. So we've got the short side here, we've got the longer side here. They're not in the same orientation, they kind of rotated and flipped around. So you got to make sure you're matching them up. And now decide which ones you want to use. Again, we have to use the x here, and the x is going to get matched up with the 30 here. And, well, then I could use the long side here. So which side do I use over here? Well, you've got to use the long side over here. So now we can use that information. So these two pieces we don't actually need to set up a proportion. We have, let's do small to large. So we can set up x over 12. And then we want this to be small to large. So what's going to go on top? It's got to be the 30. And what's going to go on the bottom? It's going to be 72. And now we can multiply this. We have 72 times x equals 3 times 12 is 36 times 10. That's going to be 360. And we can divide both sides by 72. X equals, we get for x equals, what is 360 divided by 72, comes out to 5. And go back to our picture, make sure that it makes sense. Let me just erase all this so we can see. So does 5 make sense? We're saying that this side here is 5. And yeah, that's going to be the short side, and just by the picture it looks like it's a lot shorter, about half as short as this side here. So 5 seems like a good answer. So that's how you're going to solve these similar problems, setting up a proportion, just making sure that you match up the correct sides. If you have any questions, let me know. Bye!